expertise in generating human-like audio with image extracted text, a real-world project workshop. Now, I would like to thank Tyler for joining us today as a speaker. Tyler, welcome. Please introduce yourself to the audience.
Yeah, thanks, Zainab. My name is Tyler Smith, and like she said, I'm from the United States, from Iowa more specifically, so kind of right in the middle of the country. And like she said, I'm an Apziva resident, closing in on a year now. I think it'll be a year around my birthday, July 24th. So a little more than a month away. Through that time, I've been worked on. This is my fourth project. The first two were just like using traditional machine learning techniques, and then the last two, including this one, were more focused on deep learning. And a little bit of background on me. I think this is one thing that kind of to take away from people who are wanting to transition into the field. I am not in any way, shape, or form I come from this field from. I was in the service industry for 10 years or so. I was a caddy valet at a golf course, and I was turning 30, and I was like, you know what, I'm not want to do this anymore. So I was just like, I want to do something completely different. And this is 2023. And so that was kind of when ChatGPT was kind of making a splash in the news headlines, and it kind of just piqued my interest. Nothing too crazy, but it was just kind of a whole amalgam of things that just kind of was just like, you know what, I'm just going to just give this a shot, just something at a right field. And I feel that I did a boot camp, and then I was lucky enough to get Sami, who's on the call today. He was my mentor through that, and he's like, hey, after you get done with this boot camp, how about you look into Apziva, because it gives you a real world experience or real world data sets to work with. It's been great. So if you don't get anything else out of this workshop, just say that, hey, you don't have to be, a statistician or a mathematician or a physicist or anything. It does help to have maybe some of that background, but so just let you know, I'm it's been a good experience. So so without further ado, let me get into this. Hopefully everyone can see what I'm looking at. Can everyone see the screen all right? Is everyone good?
Yes.
Okay.
Yeah.
All right, so what we're going to be looking at through this notebook, and I guess one other notebook that I have, we're going to be looking at how to extract text from an image and then generate human-like audio from that extracted text. So the meta category of this would be OCR, or optical character recognition, and that was kind of a new thing that emerged in the early 1900s. And thank you to Wikipedia for doing kind of the history behind this for me. Emanuel Goldberg was the first one to develop a tool that could scan text and then be translated into telegraph code. And then since then, over the 100+ years, seen a drastic leap in that sort of technology, going from enterprise software solutions such as like Ray Kurzweil. I think he was one of the first to do that. If you've never read the Singularity is Near, he kind of made that popular. So he was the first to kind of do that in the 1970s and 80s. And then now in the last 10 or so years, it's been going to cloud-based and smart IoT device technologies such as smartphones and smart glasses. So this looks at using one model to extract text from an image, and then as well there's two other text-to-speech models which will take that extracted text to generate human audio. So, and those two models will be Sesame and Dia. So let's go down to one of the pictures we're going to be working with. And so this picture was from the book of Genesis, and I wanted to use this photo or this image because we see that there's not only the text in this first and second column that's more applicable to what we want, but there's also there's images, or there's words on part of the image that we don't really want, such as these words over here. There's also footnotes that I don't really want to extract. There's other references to other biblical passages that I don't really want, and there's other preliminary explanations of how the chapter's laid out that I don't really want that either. So I was like, you know what? We'll just use this as a test to see if I can just get from in the beginning and to God saw how good it was, to see if I can extract just that text. So I actually ran this morning, and it was kind of good that it didn't quite give me the answer or the text that I was wanting. So we're going to use, and I'll get to that, but so we're using Google's Gemini 2.0 model, and what we're going to do is we're going to provide it an image, and then I'm going to prompt it to say this. I'm going to say, extract the text that is on the open page, or the page open page in the image. Do not add any extra text or special characters to your response. If sentences are incomplete or on the opposite page, do not extract that text in your response, and do not extract footnotes, abbreviations, page verse numbers, or page headings. So pretty much all the stuff that I just said that I didn't want, well, I just said I don't want it in there, so please hopefully do your job. And so I ran this morning, and it was good because I got exactly what I wanted. I wanted to have it start in the beginning, which, like I said up here, that's what I wanted. I wanted to stay in the beginning and from to God saw how good it was. So that's good. But then if I look at all the text, now we are seeing all, let's see, God, I think right, all of these texts right. Let's see, I think some of these, yes, oh, sorry, right here. So if you see this text right here, you can see that it's extracting some of the words and the characters that were not on the page that I specifically wanted. So you can see that it is some of these words right in here. So like I said, it wasn't good that it didn't do its job per se, but it was good to just give this example of like, hey, you know what, you can run this a lot of times, you can get what you want, but sometimes it might not give you what it wants or what you want. So I thought that was good. But then how do we actually tell if what we're extracting is actually good? You know, it's like what kind of metric can we use to compare the extracted text to say, hey, you know, we're getting a good number. And so that's where a BLEU score, BLEU score, comes in. If you want to look that up, it's in this. You can just look up BLEU, a method for evaluation for machine translation. And in that, they quote, the closer a machine translation is to a professional human translation, the better it is. And obviously, that is what we're wanting. We're wanting this machine to see how well it translates into what the actual text is. And so partly why I wanted to use the biblical verse was I knew where I could get something from the internet that was the actual text to compare it to. So using the Vatican, or I went to the Vatican website and then copy and pasted the first two books of Genesis into a TXT file. I read it in here, and then what you can do is I can provide the ground truth from the Vatican website, and then with the text that we extracted from the image, and we can get a percentage score of how good it is. And so in this case, it was close to 75, and I've ran it a couple other times and I've gotten north of 80. And part of that too is, and like I said, it was actually good that it didn't do its job quite as well this morning, was to see that number was a little wasn't as good as I'd got before, because it's extracting other text that I don't want. But by and large, the BLEU score is kind of I would say the gold standard, I guess, if you're trying to compare text from image extracted text. So, and then there is one caveat, and that was one thing why I wanted to use the biblical verse, is if you don't have the text to compare it to, well, it's kind of hard to, it's hard to hard to get a metric, I guess, if you don't have that text. So I don't quite know how you would do that. Maybe somebody else does, but yeah, so there's one problem that kind of sneaks in there. So now we're going to move on to the speech synthesis. So how do we take that extraction or that extracted text that we got and generate, putting it into a text-to-speech model? How can we generate human-like audio? And so some of these models, and I believe it's the DIA model, I can't remember if it's the Sesame model, one of the two, they say if you provide it anywhere from 7 to 20 seconds is optimal, because the cadence of the human voice is either really fast or really slow, depending on how slow or how short or how long the the text is. So that's why I've broken the text that's been extracted into little chunks. So you'll see in these four that I've kind of truncated down. I think the first one, this one's only a sentence long, but a couple of them have 2, 3, 4 sentences if they're really small. But yeah, you kind of want to keep that between 7 and 20 seconds. And so what I'm going to use the Sesame model, and I'm going to provide it those four chunked snippets of what I want it to say, and I'm going to play a few of these examples. So I'm just going to play 2 of them, and then I'll move down and play another 2.
In the beginning, when God created the heavens and the earth was a formless wasteland, and darkness covered the abyss, while a mighty wind swept over the waters. Then God said, "Let there be light." And there was light. God saw how good the light was. God then separated the light from the darkness. God called the light Nebuday, and the darkness he called Nebudnight. Thus evening came, and morning followed the first day. Then God said...
Sorry. Okay, so I just wanted to make sure everyone heard that all right. We're good? Okay, awesome. Okay, good. So the second one that I played was interesting because, and this is just out of the box. So it's just I downloaded the model from Hugging Face, put the text in that we extracted, and just went with it. Nothing else. And it's interesting that the second audio recording that I played for y'all, the quotation marks in some of the text that was in there, it phonemizes, I guess. I'm not a linguist either, so that's one thing, but I think that's what maybe you call it. But it's interesting that it's kind of learning to give a phonetic reference maybe to quotation marks, because I'm pretty sure that other human languages, I mean, at least in English, we don't those aren't you don't phonemize them. They're just there. Like I said, I'm not a linguist, so it's just interesting that it's doing that. So going on with Sesame, their documentation says to better the model, we need to add some context. So I just gave it 2 other verses from Exodus, and then 1 verse from, I think, John or Paul, and then 1 from Acts. And let's just see what that does.
In the beginning, when God created the heavens and the earth was a formless wasteland, and darkness covered the abyss, while a mighty wind swept over the waters. Then God said, "Let there be light," and there was light. God saw how good the light was. God then separated the light from the darkness. God called the light Nebudnight, and the darkness he called night. Thus evening came, and morning followed the first day.
So you'll notice that it's a little bit better, but and it's still learning some things that shouldn't have an utterance, I guess. But there was one time that I think it was the first couple times I ran this model, was I gave it the context, and if you listen to it closely enough, you could almost hear the audio is almost like a early televised like a grainy preacher preaching. So it's very, very interesting how sometimes it did that. And I can't remember I have if that ever did it again, but at least one time that it did that. So I thought that was uh, very interesting. So one thing before I go on was I want to make note of if if the text that can be extracted can be non-English. So one of the data set that I was given for this project, most of it was in Turkish, and then there was other parts of some of the image data set that were I guess it wouldn't be a programming textbook, but it's something along those lines. So this is one of the images, and the extracted text is down here, and you can see some of the like the S with the tail, or the or the O or the U with the diaresis, or the C with the tail, that are all present in the Turkish language. So those can be represented as well. Other languages, I don't know. That's one thing for anybody out there who is not of the English language to look into. And then another thing was, as I was saying, from like a textbook. I don't know what type of. It looks like an maybe like a. I really don't know what this would be, but but it has like IP addresses. Just just kind of different characters. That does a pretty good job. But like I was saying with the, if you don't have the text to compare it to, I don't quite know how good the translation would be, and machine translation would be. So that's one thing. If anybody out there knows how I could do that, that'd be yeah, that'd be great. But I didn't want to kind of showcase that as well. So going back to the Sesame, I did recently find that you can fine tune that model with your own data set. And so with that, here's just a small data frame of how the data set that I would use to train it on. And so what I've done is chunked it into 20 different text lines. So, and like I said before, keep it between 7 and 20 seconds. And then the path to the audio file. And so you're thinking, well, this is pretty cumbersome because you're going to have to find the audio for these, for the text. And so that's where I'm going to go to this other text-to-speech model that I referenced earlier called DIA. And so this is the text that I'm using. The same text as the other notebook. And I have chunked it just for testing, or just for the example here. I've done more, but just for the first three, these are the exact same 3 chunks that we used in the prior notebook. And I'm going to load that model in. And this is, and mind you, this is just out of the box. I provided the text, this character, the S1 or the S2, that's the voice. Those are the only 2 voices that it provides. I think that the Sesame has more voices, but I haven't really played around with that. Dia is pretty more self-explanatory, is just provide an S1 or S2. So I'm going to play 3 of these. Actually, I'm going to play 4 of them because there's a little bit more play you can do with Dia. So,
in the beginning, when God created the heavens and the earth was a formless wasteland, and darkness covered the abyss, while a mighty wind swept over the waters.
Then God said, "Let there be light," and there was light. God saw how good the light was. God then separated the light from the darkness. God called the light day, and the darkness he called night. Thus evening came, and morning followed the first.
let's cut short a little bit. Did everyone heard that? All right, good.
Yeah.
Then this one's kind of funny. This clears throat. This one has a you can provide like sniffs or clears throat or cough or whatever. So I just thought this was kind of funny to put in here.
Then God said, "Let there be a dome in the middle of the waters to separate one body of water from the other." And so it happened. God made the dome, and it separated the water above the dome from the water below it. God called the dome the sky. Evening came, and morning followed the second day.
So if you can hear that, which hopefully everyone can, it's drastically better than the Sesame model generates just out of the box. And so if I was to fine tune the Sesame model, which that's the model that I've worked a lot more with than the DIA model, just because it's a little less complex than DIA, then it really makes it easy. Is if I can chunk all of the text that I want, and then have it generate the audio from that text, and then there we go. It's pretty easy, pretty pretty remarkable that you can do that. So I've chunked it all, and that's the data engineering behind this would be very, very tedious, and it was. And if anyone has a suggestion to do it faster, to do it more easily, I'm all ears. But that would be pretty. It's pretty tedious, and so, and like this, you have to provide the text, provide the audio path. Very tedious, but once you get that, going back to this notebook, once you have that data set, you can then fine tune it, and that's what I'm kind of working on right now. I've run it a couple times. I'm still working on it, but there's hopefully some signs for success, but we'll see. But one other thing before I conclude here is I guess it'd be interesting if somebody could take a data set using somebody else's voice, train it, and then use it for malicious purposes. So that's just one kind of thing that we have to be weary of, or keep an eye out on as this field progresses, because I mean it's only going to get worse from here as the capabilities are endless with that sort of thing. And because I'm working with this, and I go, oh well, what I could, there's got to be audio from whoever out there, and you could just train a model on his or her voice, and who knows, but just something to keep in the back of your mind. But yeah, so that is all from me. Thank you everybody for listening and wanting to be here today, and hopefully you gain some insight and some inspiration maybe. Contact me on LinkedIn. I'm on Tyler Smith. If you saw the picture from Epziva's post on LinkedIn, that is my LinkedIn profile, or the profile picture. I'm not huge on social media. I think that's about the only media I have is LinkedIn and YouTube. And even YouTube, I just like videos on there. I don't really produce much. So thanks everybody. And if anybody has any questions, I will do my best. So
thank you, Tyler. Before we wrap up, I would like to hear from all the audience. We will be starting a Q&A sessions shortly, so please feel free to send in any questions or simply type them in the chat, or you can basically raise your hands to ask a couple of things to Tyler. Thanks a lot. So, any questions?
Excellent. Can you guys hear me?
Yes, we can, please.
Awesome. Hey, Tyler, question. I was looking at your voice data model, and I noticed that you were taking like the clearing throats to be false and everything with that. Do you also have anything for like rumbling noise instead of like putting like if you hear these type of sounds or something like that, to disregard them? Do you have something written in that code that's like a filter to where if it's at a certain decibel, it's not intelligible or anything like that?
Oh, that's a good question. I don't have anything in there, but that would be something to look into, to like, hey, don't you can disregard certain decibel, if it doesn't get higher than than whatever it is. But yeah, it's I don't have anything in there, but I definitely could, and probably definitely it could make a difference. So yeah, thank you.
Sorry, and so I'm not as inclined with Google Meets, but thank you. That's
Yeah.
all I had.
You bet.
Hi Tyler. So even I had one question. So this is regarding how you are sending the prompts to kind of generate the audio. So like whenever like when you set up the prompts, a key aspect is setting up the context. So like how do you ensure that it is getting the right context to generate the audio? Like how do you manage the context while sending the prompts?
Are you talking about the prompt that I
Because
initiated to extract the
yeah,
text?
yes, extract the text, and also like telling telling your model to actually speak the extracted text. So like how do you manage the context in that, because that is also like something critical part of like defining the prompts.
Yeah, totally. Yeah, so that was just trial and error, unfortunately.
Yeah.
But let's see, I guess if I should probably share. Sorry. Okay. But yeah, if you can see my screen. Yeah, so it was this line here through the Google Gemini 2.0. That was just all trial and error because I think I initially said, just extract the text on the open page of the image, and it did a pretty poor job because I mean it was getting everything. It was even getting the image or the characters that were actually seen through from the other side because on some of the images I do have some of that, so some of the characters are popping up. But yeah, that was all trial and error, and I could probably add on to that. But like I don't know if I mentioned this, but most of the time that I would run this with this said prompt, most of the time, it was giving me exactly what I wanted and with very minimal extra characters. And with that blue score that I mentioned, it was getting up somewhere into like the 85 range from the actual like ground truth text. But then once you put that, like we're just going to use Sesame for the example, you're just going to put that text that was extracted, and then it's going to generate that text that's been extracted. So yeah.
And just to like, is there a way to kind of a verification or validation method so that we know that it's like how is there a way we can measure that it is being accurate, how accurately it is being generated? Is there some sort of a mechanism for that too?
Like a validation for like the voice.
The final output, like yeah, for the voice and the text. So like how do we validate that the text or the voice that is being generated is actually accurate or in line with the text itself? So like, is there a way to like like somehow validate that thing?
Yeah, I don't know if there is a way to validate it. I guess the only way to validate it, I guess to my own ear, and this is probably just a terrible way to go about it, but like I was saying with this, with that second audio clip, the machine was learning to represent the quotation marks as some sort of phoneme in the human language, which is obviously I don't think that any human language has a phoneme for quotes. Maybe they do, I don't know, but definitely not in English. So that's kind of one of the things that you just kind of that I'm like listening to, and it's like, well, that's not quite right because that's just not what an English speaker would do or say. But yeah, I don't really know for certain if there's a metric that you can validate how good an audio is, unless it's just by the human ear. I don't know. That's probably a terrible way to do it, but yeah, I don't know.
So it's like mostly like intuition based, like you have to like kind of do it by yourself and just kind of like have like that like certain way to like like, that you have the text with you, you have the audio, just kind of try to find the accuracy within that.
Yeah, I mean, yeah, as far as I know, I mean, if anybody on here knows of anything different, yeah, please let me know. But yeah, that's about all I know as of now. But yeah, I'll just keep looking into it and see if there is some sort of validation metric. But yeah,
Got it. All right, sure. Thank you so much, Tyler.
yeah, thank you. Thanks for the question.
I believe Osama raising his hands.
Yes. Hi, Tyler.
Hello.
Great session. Loved the work you've done.
Thank you.
So you mentioned a very interesting point, like this could be potentially used maliciously. So I was just wondering, like, how would we go about, making AI safer? This is like a very big concern these days. Like how AI, at the rate AI is progressing, like how do you make it secure? Like, would there be a way to identify or like restrict someone from copying someone's voice, or at least identify like if a voice is AI generated or if it's like an actual human being's voice,
Yeah,
So-
the actual voice instead of something that's been generated from their actual voice.
Exactly.
Yeah, that's
How-
and it's not. I actually just I put it in here just within like the last couple days that I wanted to make note of that because it was actually my mom who was like saying, hey, these people are using so and so's voice to con other people into giving money or whatever. It's just a new it's a new technology, same sort of deal. It's like, all right, we're it used to be just like phone call. Well, yeah, it still would be a phone call, but from somebody far off and tricking elderly people to give them money or whatever. It was just a new form of that. But yeah, I don't know where I don't know how we make it safer. I just think we people who are in this profession just needs to just kind of be aware of that. I know that Sesame and Dia might have this in there as well, but I know that Sesame, they have something called a watermark that I don't quite know exactly how it works, but it's something to do with this has been generated by a machine and it's not the real thing. How well that can do in preventing malicious behavior, I don't know, only time will tell. But yeah, they do have something in these text-to-speech models that tries to help. And on their documentation on GitHub, they say as a responsible AI citizens do all this stuff, but it's like, hey, all those malicious people out there really are not going to give two looks at that. They're just going to do it for their own malicious purposes. But I think it's just we're in the field and we just kind of need to be just aware of it. So
All right, great. Thank you.
Yep. Thanks, Osama. Let's see. Alvin, I think.
Yeah.
Yep.
Hi, Taylor. Thank you so much for the very insightful presentation. Yeah, it's amazing what AI can actually do. I'm gonna be starting on this project as well.
Oh, nice.
And
Yep.
the previous one I worked on, I struggled to make the environment working with large language models, getting the environment right, and those installations, some of them there will be conflict. How easy or difficult was it to install the correct environment so that there is no conflict with running the different models that you were running there? And do you have to pay for some of them? Obviously, I would think you need GPU and not necessarily a simple CPU for that.
Yeah. So, yeah, that is one caveat. Yeah, if you're using a CPU, it's going to take a lot longer. I ended up buying from Google the 500 compute units for like $50, I think, and it lasted me for I think like three months, I think. So that was a pretty good that was a good purchase because I did not want to be sitting here for hours and hours when I could, just spend the $50, just have that GPU whenever I connect or whenever I want it, essentially. So yeah, I would say that I would just go and you can buy, I think, 100 compute units for a little less than $10. So I would definitely do that. But concerning just to like, are you asking to install these? Are you asking to like in how to install the models?
Yes, for some of them, when I was installing during the previous project, some of them there would be sort of a clash, and you need to. I guess most of it was caused by trying to do things on a CPU and not a GPU, because when I moved to GPU, things really improved, but that struggle was there initially, and I had to kind of purchase some of the large language models, and I know that there are some good free ones, but some you have to purchase. So yeah, I just was wondering how difficult was it to get that environment? Were there no conflicts? I know that I had to block TensorFlow so that there is no clash, because I was in a PyTorch environment, things like that, to get the environment for all models to run without conflicting. That's just what I wanted to get insight on. Thanks.
Yep.
So, any other questions?
Okay. Yes. First of all, I would like to thank Mr. Smith for this wonderful program. I mean, it was a really a wonderful presentation there. Okay. My question goes like this. Okay. Like I want to ask, did you in any way experience kind of any error in your OCR? Like in terms of language, like did you experience any error? Like even okay, if you did experience any error, like did you like how do you manage to handle it? I don't know if you understand my question.
So how did let's see? Is
I mean,
it
OCR, that is optical
optical character recognition?
character recognition. Yes, like I'm asking, did you encounter any error in non-English scripts like
And so I guess I'm not quite understanding the question. So did I experience any problems with
yes,
with
exactly. Like any problem at all, like when you're setting up this OCR thing, like did you encounter any problem?
I guess the only problems that I really had was just I guess getting all of the right dependencies, I guess, from the models. But once I got that, it was providing me pretty reliable, pretty I would say reliable audio from the text that I was giving it. So, but yeah, just getting the models to work, just having to install the dependencies. And at one point I was for this model prep, I was wanting to just run it all in one notebook. Well, then you had dependencies from the DIA and the Sesame model that were conflicting, and it was like, I'm just gonna just throw into two separate notebooks. But other than that, it was a pretty I wouldn't say seamless
Okay.
project, but it was there's some little headaches, which there always is. So, but nothing too earth shattering.
Okay, thank you so much.
I believe there's one question on the chat. So,
Yes.
Hello, Tyler.
Oh, yeah.
Yeah, can you hear me?
Yep.
Yeah, my name is Teja. Thank you so much for this presentation. I have this question regarding models. You're talking about model. Like, how did you selected the model? Like, what model you have selected, and what was the research you have done before, like selecting this model? And yeah, would like to know.
Yeah, so I think I was using some of like the really early models like Idefix, and I can't remember the other one. But Sami, he actually turned me on in I think early or late February. He's like, "Hey, I just got notification, or not notification, but maybe he's looking on LinkedIn or something about this, this new text to speech model. So we should try it." And then we did, and then we saw that Dia
Yeah.
was there as well in the next few weeks after that. So we're just using it, and I mean both of us were floored at how well it generated human like audio.
Uh,
There wasn't really a whole I guess there wasn't really a test of which models to use. We just were like, wow, these are really good at generating human like audio. And so we just use these two, and showcased them. So
yeah, and also other queries like multiple languages, is this model gonna support like if you like train this model with multiple like different language, can it possible like this model gonna work? Or
that's one question that I had myself, and I was looking at I don't know if Sesame can do that, but I know that the Dia model has capabilities of training it on, I think, 20 or so languages. And that's one thing that I haven't got around to, but it'd be interesting. And like I noted in the presentation, that it was able to extract the Turkish language or some of the Turkish text.
yeah,
That I was like, well, I kind of want to try, seeing if it'll work with Turkish. So that'd be kind of interesting. But yeah, I just haven't got around to it. But there is capabilities, I think, out there for some of these models. So
thank you so much, Tyler.
yeah. Let's see, what was that chat? Let's see, Josh, is it possible to upload, let's say, the Oxford English Dictionary and generate a meaningful paragraph of that? I don't know. That'd be interesting. That would be interesting. I don't know. Let's see, Krishna. I'm sure you could, but I guess that'd be. Well, I guess that'd be what the LLMs have been trained on. So, see,
Yeah,
Krishna.
I was
Oh yeah.
thinking like
Oh, sorry.
like instead like because it would work maybe similarly to instead of uploading a photo, I guess uploading the whole Oxford dictionary and then having
That's
trained the model to what's this? Like be like, oh, please generate a paragraph about summer. So it goes randomly and chooses any words and then creates a paragraph about summer, something like that.
yeah. That'd be. Yeah, I don't know. That would be interesting just to see what you could prompt the model to. If you gave it just a picture of the English dictionary, or I guess English dictionary. And just see what you could prompt it to do. That would be interesting. I don't know. I haven't done that. So, but yeah, good question. Let's see. Let's see, Krishna. Where did you start or where did you jump in at? Oh, sorry. Okay. Yeah, you got there. Yeah, never mind. Nope, Zainab's got that. So yeah, we're good. Okay.
Yeah, for those, we're going to share the record after the meeting ends. Thank you.
Perfect. Awesome. Cool. Cool.
So that brings us to the end of today's workshop, I believe.
Cool. Okay.
Yeah, yeah. A huge thank you to Tyler for sharing your insights and walking us through the process of building a generating human-like audio. It's always inspiring to see the work of our AI residents are doing there. So stay tuned for more hands-on sessions where we'll continue to explore cutting-edge AI and data science topics with industry experts and Upsiwa alumni. So thank you all for joining us today. We look forward to seeing you at the next one.
Yeah. Thank you, Zainab. Thank you, everybody, for joining. Appreciate it.